We are given this f of x, which is basically a piecewise function type, and given as cos x if x is less than 0, 0 if x is equal to 0, and 1 minus x squared if x greater than 0. And we have to understand or probably explain why this function f of x is discontinuous at the point a. So we have been given the point as a equal to 0. So first, we will understand the definition of continuity, which I have given over here. There are three conditions that must be satisfied in this order so that we can say that the function is continuous. And if any of the conditions is not satisfied in the order, then we can say that the function is discontinuous. So the first condition is the function f of a is defined. So whenever we are finding the continuity, we have at any point, let's say the point is a, the function has to be defined at the point a, that is f of a has to be defined. And then the next condition is the limit of the function around this point, that is at the point a, should exist. So basically this is another way of looking at the one-sided limits or exist as well as they are the same. That is the left limit, left-sided limit as well as the right-sided limits. They should exist and both should be the same. Only then we can say that the limit of the function at that point A exists. And in the third condition, we have a limit of f of x, x approaches A is equal to A. So it's basically these two conditions has to be same. The result of these two conditions has to be the same. Only then we say that this third condition is satisfied. So which means when all the conditions are satisfied, we can say that the function is continuous. Otherwise, if any one of the condition is not met at any or at this order, then we say the function is discontinuous. So let's start off with checking each of the conditions. First, we have to find if f of a is defined. For our given problem, the a equal to 0. So which means we have to find f of a is defined. So let's see if this is defined. We have this f of x and we have to determine f of 0. Clearly we can see that at x equal to 0, f of 0 is equal to 0. So I can write down this as f of 0 equals 0. So we have some value for f of 0. So this is clearly defined, which means the first condition is satisfied. Now let's move on to the second condition, which is the limit condition. So let me write down this. So this is basically limit of f of x, x approaches a, this should exist. The other way of looking at this definition is splitting this into two parts, as the first part goes like this. That is, we have to find the limit, the left-sided limit. I write down this as x approaches a minus. This is basically the left-sided limit. And another limit is the right-sided limit. I write down this as limit x f of x, x approaches a plus. This is the right-sided limit. These two basically has to be the same, that is they should be equal. So only when they are equal we can say that the limit of the function exists. So let's do that. So I'm going to do the next step. So the next step I can write down this as, since our point a equal to 0, I write down this as x approaches 0 minus, and this is equal to limit of f of x, x approaches 0 plus. Now we go back and substitute the corresponding function definition when x approaches 0 from the left as plus 0 from the right. Basically, when x approaches 0 from the left, it is equivalent to x is less than 0. So when x is less than 0, we have to use this part. And when x approaches 0 from the right, we have to use the other thing, that is x is greater than 0. So we have to use this part. So which means I have to use the f of x as cos x for the left side limit, and I have to use 1 minus x squared when I use it for the right sided limit. So let me copy it here. So in the next step, I'm going to write down this as a limit of cos x for the left side limit. So this is basically into sorry, it is 0 minus, and this should be, or we can verify that if it is equal. So limit of the right sided function is x greater than 0, which is 1 minus of x squared. So I can write down this as 1 minus of x squared. X approaches 0 from the right. Now let's do the substitution. So this is equal to, I can plug in 0 for cos x. So this is basically cos of 0 is equal to 1 minus x squared. I'm sorry, it is, since I'm making the substitution, this is, I'm just verifying if it is equal to 1 minus 0. Notice that I'm not equating here, I'm just verifying if these two are exactly the same. So cos 0 is 1, is it equivalent to 1? Yes, both sides are the same, which this is a true condition which is met, which means the left-sided limit is equal to the right side limit, and this implies the limit exists of the function at x equal to a, that is 0, this exists. So this is basically another definition for when we check if the limit exists, when both the left side limit and the right side limit should coincide, or they should be exactly equal. Only then we say the limit exists. So which means for our problem, we can see that the second condition is also met. Now let's move on to the third condition, which I can do it over here. The third condition says limit of f of x, x approaches a is equal to f of a. So it's basically we are checking that the results of both the first and second conditions are exactly the same. Let me use this. We can say that limit of f of x, this is in fact equal to 1. After we have found out limit of f of x, x approaches 0, this is equal to 1. So let me use this here. When I use it here, I substitute 1 for this one, and f of a is that is f of 0, that is the first one. We have found out that it is 0. So clearly 1 is not equal to 0. So that is why the third condition is not met. You can see that this condition is not met. Only the first two conditions are met. So we can clearly see that the function is discontinuous.